Hello everybody, and welcome back to another Big Ideas lesson. Today we're going to talk about 9.4, completing the square. Now, completing the square is a little bit of a complex process, and I really want you to see the reasons why we would even do such a thing. Before we jump into that, I want us to get some practice so we can see what we're thinking. Let's take a look at these problems here, these three problems. Well, if we were asked to solve for x in these problems, it wouldn't be too difficult, would it? For instance, in our first problem, how could we find x if x squared equals 64? Some of you may even be able to do it in your head. The main thing is, the opposite of squaring something is square rooting it. So if we really wanted to get our x all by itself, we could just square root both sides of our equation. Well, the square root of x squared is just going to be x, but the square root of 64 we have to be very careful about. Yes, it's true that the square root of 64 is 8, but there's a second answer. Whenever you take the square root of a whole number, you're always going to get two different answers. Positive 8 is one of our answers because 8 times 8 is 64. But you know what else is our answer? Negative 8. That's right, because negative 8 times negative 8 will also give us 64. So it's like we have two answers, x equals 8 and x equals negative 8. And even if we take things up a notch, it's not too crazy. Let's take a look at x minus 3 squared equals 16. Well, again, we want to get x by itself. X is trapped inside of parentheses with this minus 3. So we wouldn't touch that until the very end. But this square is on the outside, so, just like the last one, we square root both sides. Well, x minus 3 squared and then square rooted, it means the square and the square root will cancel out. We'll just be left with x minus 3. So x minus 3 equals, and what's the square root of 16? Hopefully you got both answers, plus and minus 4. So x minus 3 equals positive 4, and x minus 3 equals negative 4. From here, you can either choose to split your equation now or split it later, but I'm going to split it now just to show you what this really turns into. Because it could be plus or minus 4, we want to have two possibilities, right? In our first possibility, we'll explore what happens when x minus 3 equals positive 4. In the second, we'll explore what happens when x minus 3 equals negative 4. Well, in both cases, if we want to get x by itself, we've got to get rid of this minus 3. To get rid of minus 3, we add 3. So if we add 3 to both sides, we end up with x equals 7 here. And if we add 3 to both sides on this problem, we end up with x equals negative 1. So far, so good. The last type of problem I want you to try on your own. See if you can simplify or solve for x when 3 times the quantity x plus 7 squared equals 27. Pause here and see if you can get it. So how'd you do? Did you figure out that first we had to divide both sides by 3 because of reverse PEMDAS? Then we could square root both our sides, giving you x plus 7 equals positive 3 and x plus 7 equals negative 3. In this particular problem, I actually did the subtraction step first instead of splitting it, because you can really split it at any time. So in other words, I would get x equals negative 7 plus or minus 3, which would give us x equals negative 7 plus 3, which is negative 4, and x equals negative 7 minus 3, which is negative 10. This is how we learn to solve for x by square rooting. However, this is only the prequel to what completing the square is. These numbers all worked out very nicely, right? I mean, the square root of 64 is perfectly 8, and the square root of 16 is perfectly 4, and the square root of 27, well, when we divide it by 3, that's 9. The square root of 9 is perfectly 3. However, some problems might not be perfect. In fact, they might be very far from it. First, let's explore what completing the square means, and we'll talk about some of these imperfect problems. So right now we're on page 293 in our student journal. Let's talk about completing the square. So what does completing the square refer to? Let's say, for instance, we had the equation x squared plus 6x plus 9, or the polynomial x squared plus 6x plus 9. What's really nice about a problem like this, say we set it equal to 4, just for an example. What's really, really nice about a problem like this is we can factor x squared plus 6x plus 9 into something very useful for us. If you factor this using a combinator, we would see that we're trying to find what multiplies to make 9 and adds to make 6. Well, hang on. 3 times 3 is 9, and 3 plus 3 is 6. So if you wanted to, you could factor this as x plus 3 times x plus 3 equals 4. And hold on a second. X plus 3 times x plus 3, well, that's just x plus 3 squared equals 4. This is just like the problems we did over here, where we had x in parentheses squared. This can be solved by taking the square root of both sides. We'd get x plus 3 equals plus 2, and x plus 3 equals negative 2. However, what if that 9 didn't exist? Completing the square is the process which gives us a number that will make this type of problem work. So let's say, for instance, instead of all of this fun stuff, we had x squared plus 6x equals negative 5. Well, this cannot really be factored in the way we know it. Yes, technically for this problem, you could add 5 to both sides and factor it, but for the purpose of this example, we're trying to see if we can get our problem into a state like this, which we can't. There's no c value, right? Completing the square is a process by which we give a c value to our trinomial, or our binomial, making it into a trinomial, I should say. Completing the square is giving us a number here that will let us factor it perfectly. We know from the example up here that this number is going to be 9. We want it to be plus 9. But let's figure out how to get that magic number in other cases. To complete the square, when you have a binomial like this, you first want to take your b value and halve it. The formula to find this magic number is b over 2 squared. So in this problem, what was our b value? Well, our b value is 6, right? So to find this missing number, we're first going to take 6 and divide it by 2. Then, when all is said and done, we're going to square it. What's 6 divided by 2? 6 divided by 2 is 3. And what's 3 squared? 9. That's why 9 is the magic number that works here. That's why 9 is what factors perfectly. It's 1/2 of 6 squared. So let's add plus 9 to both sides. What that'll give us is actually x squared plus 6x plus 9 equals 4. Also remember, we can't just magically add to one side, we have to add to both. This is just like the problem we did up above, and we could finish this problem in the same way. We could finish it by realizing that this perfect trinomial ends up giving you x plus 3 times x plus 3, or x plus 3 squared. That equals 4. Then we could square root both sides. Bam, 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 giving you x plus 3 equals plus and minus 2. Well, if it's x plus 3 equals 2, we know that subtracting 3 from both sides will give us our answer, x equals negative 1. And if it's minus 2, we still want to subtract 3 from both sides. So we subtract 3, giving us x equals negative 5. Completing the square is just a process of starting here from this problem and getting something that we can actually factor. Perfect. Let's do another example. Well, before we do another example, let's write down the definition. The definition of completing the square is for an expression x squared plus bx, you can add a constant, c, so that it becomes x squared plus bx plus c, a perfect square trinomial. We call this completing the square. For this expression, you can add a constant c to the end, so it becomes x squared plus bx plus c, a perfect square trinomial. On page 294, we'll be able to actually get some practice with this. So for questions 1 through 6, it's just asking you to complete the square, then factor the expression. Now, I'm going to show you examples number 1, number 3, and number 2, so we can start to see a pattern form. Once that pattern is formed, we'll be able to take on the incredibly tough numbers 5 and 6. So, to complete the square, we're just asking, hey, what's the magic number here, our magic c value, that will make this a perfect square trinomial? Well, we know our formula. The formula is that missing c value is b over 2 squared. So what's our b value here? It's 12. So 12 divided by 2 and then squared should give us that mystery number. Well, 12 divided by 2 is 6, so it's 6 squared. 6 squared is 36. So to complete this square, we turn it into plus 36. When you factor this, though, this is the interesting bit. When we factor this, we will end up with the answer x plus 6 squared. What's the reasoning for that? Well, if we go to our separate sheet of paper here, x squared plus 12x plus 36, we factor using a combinator, we get 36 on top, 12 on bottom, and 6 times 6 makes 36, and 6 times 6 makes 12. That's why we would end up with x plus 6 times x plus 6, which, when we put them together, is just x plus 6 squared. Interesting. In fact, didn't our last problem sort of go the same way that we did? The last problem we factored, it became x plus 3 squared, or x plus 3 times x plus 3. Very interesting. Let's do one more, and let's see if we can pick up on the pattern for how it'll factor. Let's do problem number 2. Well, we'll do problem number 3 for the spacing reasons. So we need to find our mystery c value that will complete the square. Our mystery c value can be found using this formula. C equals b over 2 squared. Well, 4 is our b value. Divide it by 2 and square it. That's 2 squared, which is just 4. So 4 completes the square. From here, we just need to factor this. So we set up another combinator. 4 on top, 4 on bottom. Oh, but would you look at that? 2 times 2 is 4, and 2 plus 2 is 4. So we could factor it as x plus 2 times x plus 2, or in other words, x plus 2 squared. Here's the pattern, and I want to talk about this on the previous page. To factor these trinomials, it's always going to be x plus 1/2 of your b value squared. Let me show you what I mean. In this original problem, we said that 1/2 of b was 6, right? That's why we got 6 here. So we're just going to write our factored trinomial as x plus 6 squared. The number that goes inside of the parentheses is just that 1/2 of b value, and it's always going to be taken to the second power. So without even really doing much, we can try it with this problem too. To complete the square, we do 1/2 of b and then square it. 1/2 of negative 14 is negative 7, so what's negative 7 squared? It's going to be 49, so plus 49 completes the square. But remember the pattern. The factored version is going to be x plus whatever 1/2 of that value is. And then divide it by 2. What's 1/2 of negative 14? 1/2 of negative 14 is negative 7. So it's x plus negative 7 squared, or in other words, x minus 7 squared. The pattern works, and if you factor this as a trinomial, you'll find it's the exact same answer, x minus 7 squared. Down below, for 5 and 6, we have a little bit of a problem, but it's only going to make it a little bit tougher to solve. The problem is, if we try completing the square here with our b over 2 squared formula, well, our b for number 5 is negative 7. Uh-oh. Negative 7/2 is not a whole number. Since negative 7/2 is not a whole number, you could put it into decimal form and then square the decimal, but that'd be an even messier decimal. Do we remember how to square something that's a fraction? Remember the trick. If you have an exponent outside of parentheses, you just put it onto everything that's in parentheses. So negative 7 squared, or negative 7 times negative 7, is 49. And 2 squared is 4. Negative 7 over 2 squared is 49 over 4. That's what completes this square, 49 over 4. But, of course, we want to write this in our factored form as well. It's always going to be x plus or minus this number here, this 1/2 of b. So it's x minus 7/2 squared. For number 6, we're going to similarly solve it, and it's similarly going to be a little bit tough because if we take our 1/2 of b, we end up with 11/2 squared. Again, we can just take it and interpret it as 11 squared over 2 squared. Well, 11 squared is 121, 2 squared is 4. That means to complete the square, we would add 121 over 4. And that means that, last but not least, our factored version would be x plus 1/2 of b, which is 11 over 2 squared. Whew! Those were some nasty problems. They were tough. So instead of those nasty problems, let's take a look at one that's a little bit easier where we can put it all together. Let's take a look at problem number 8. Problem number 8 is x squared plus 2x equals 3. And in fact, let me do it on a separate sheet of paper here, just so we have enough space. I was running very low on space there. So on this separate sheet of paper, I'm going to write down my problem. X squared plus 2x equals 3. And we want to solve this by completing the square. Well, to complete the square, we're really looking for that magic number that we could put here that would make this a perfect square trinomial. Just remember, we're also going to have to add it to the other side. Well, let's complete the square then. To complete the square, we do 1/2 of our b value squared. What's our b? Our b is 2. So this is 2 divided by 2 squared. We know 2 divided by 2 is just 1. And what's 1 squared? 1 squared is just 1. So we're only going to add 1 to both sides. We're ending up with x squared plus 2x plus 1 equals 3 plus 1 is 4. Whoops, I don't know why I wrote down 3 after I just said 4. Well, how do we solve this? Remember, this can be factored as a perfect square trinomial. So we recall that it's always going to be x plus 1/2 of our b value, 1/2 of 2, we said is 1. X plus 1 squared. Don't believe me? If we factor this the normal way by setting up a combinator, we put 1 on top, 2 on bottom. We know that 1 times 1 is 1, 1 plus 1 is 2. So it's x plus 1 times x plus 1, which you can rewrite as, oh, look at that, x plus 1 squared. Mr. Strager does not lie. The last thing we need to do is solve. So how do we get rid of a square? By square rooting both sides. Well, this would leave us to x plus 1 equals positive and negative 2. If we want to get x by itself, we could subtract 1 from both sides, meaning our final answer is going to be x equals negative 1 plus or minus 2. Negative 1 plus 2 would give us x equals 1. Negative 1 minus 2 would give us negative 3. These are our two answers. Now, there are some problems that are a wee bit tougher. What if I gave you a problem that has an a value? What do I mean by that? Let's say we had the following. Let's say we had 2x squared plus 12x. Let's do equals negative 10. Well, we know that since we moved our constant to the other side, it's minus 10, we can simply try to get this by completing the square. However, we've never completed the square with an a value before, and it does mess things up slightly. If you have an a value and you're trying to complete this square, factor out the a value first. What do I mean by that? Since both of these can be divided by 2, let's take the 2 out first, giving us our x squared plus 6x plus some mystery number in parentheses equals negative 10 plus that same mystery number. Now we know how to complete the square like this. In fact, we already completed this square in the examples we did before. What's 1/2 of 6 and then squared? Well, 6 over 2 is 3. 3 squared equals 9. So let's add 9 to both sides. Here's the problem. We added 9 here, but would it really make sense to add 9 here? If we remember that we factored out this 2, we're adding 9 into the parentheses. But that's not what we're adding to this whole side in general. We're adding whatever 2 times 9 is, right? If you factor out a 2 at the start, you're going to multiply whatever you add by 2. We're actually going to add 18 to the other side. I know, super, super weird vibes. But just remember that if we were to expand this back out again, if we were to multiply all these by 2, this number would really be 18. Whatever number you get in parentheses, multiply it by the a value you factored out. Simple as. So we would end up with this, 2 times x squared plus 6x plus 9 we can factor as x plus 3 squared. Negative 10 plus 18 is 8. Now we can solve this just like we solved the last couple problems. We got to undo it. So we divide by 2 on both sides to get rid of this 2. X plus 3 squared equals 4. We take the square root of both sides. The square root is going to give us x plus 3 and positive or negative 2. That means our answers are going to be x plus 3 equals plus 2, x plus 3 equals minus 2. No matter what happens, we're going to subtract the 3 from both sides, giving us x equals negative 3 plus or minus 2. One of our answers is x equals negative 1, and one of our answers is x equals negative 5. All right, everybody, that's the conclusion of these notes. If you have any questions, feel free to ask, because completing the square is a very tough process. But in the next lesson, 9.5, we'll be learning a method that most mathematicians use, and it's a lot quicker, something called the quadratic formula. With that said, have a great rest of your day.